NVIDIA Omniverse is a scalable, end-to-end platform enabling all industries to build and operate digital twins for scientific research, infrastructure, product design, architecture, and more. Now, Mercedes-Benz is using Omniverse to optimize new production and assembly facilities. Building a car requires thousands of parts and workers all moving in harmony. Using digital twins created in Omniverse, an assembly line for a new model can be reconfigured in simulation without interrupting current production. Production planners can synchronize plants around the world, enabling over-the-air software updates to manufacturing equipment, streamlining operations while improving quality and efficiency. Mercedes-Benz is preparing to manufacture its new EV platform at its plant in Rastatt, Germany. Operations experts are simulating new production processes in Omniverse, which can be used alongside existing vehicle production. This virtual workflow also allows the automaker to quickly react to supply chain disruptions, reconfiguring the assembly line as needed. Using NVIDIA AI and Omniverse, Mercedes-Benz is building intelligent, sustainable factories that improve efficiency, reduce waste, and continually enhance vehicle quality.
Now, Huang can simulate infinite scenarios at scale while measuring operational KPIs, such as throughput, efficiency, and utilization, all before deploying changes to the physical warehouse. Together with NVIDIA, Huang and Accenture are reinventing industrial autonomy.
The future, that's incredible. Everything is in simulation. In the future, every factory will have a digital twin. And that digital twin operates exactly like the real factory. And in fact, you could use Omniverse with Cosmos to generate a whole bunch of future scenarios, and you pick, then an AI decides which one of the scenarios are the most optimal for whatever KPIs, and that becomes the programming constraints, the program, if you will, the AIs that will be deployed into the real factories. The next example, synthetically generated motions. And from those motions, the AI can learn how to perform a task. Let me show you how that's done.
Developers around the world are building the next wave of physical, AI-embodied robots, humanoids. Developing general-purpose robot models requires massive amounts of real-world data, which is costly to capture and curate. NVIDIA Isaac GR00T helps tackle these challenges, providing humanoid robot developers with 4 things: robot foundation models, data pipelines, simulation frameworks, and a Thor robotics computer. The NVIDIA Isaac GR00T blueprint for synthetic motion generation is a simulation workflow for imitation learning, enabling developers to generate exponentially large datasets from a small number of human demonstrations. First, GR00T Teleop enables skilled human workers to portal into a digital twin of their robot using the Apple Vision Pro. This means operators can capture data even without a physical robot, and they can operate the robot in a risk-free environment, eliminating the chance of physical damage or wear and tear. To teach a robot a single task, operators capture motion trajectories through a handful of teleoperated demonstrations, then use GR00T Mimic to multiply these trajectories into a much larger dataset. Next, they use GR00T Gen, built on Omniverse and Cosmos for domain randomization and 3D to real upscaling, generating an exponentially larger dataset. The Omniverse and Cosmos multiverse simulation engine provides a massively scaled dataset to train the robot policy. Once the policy is trained, developers can perform software-in-the-loop testing and validation in Isaac Sim before deploying to the real robot. The age of general robotics is arriving, powered by NVIDIA Isaac GR00T.
Here it is. Our brand new GeForce RTX 50 series Blackwell architecture. The GPU is just a beast. 92 billion transistors, 4,000 TOPS, 4 petaflops of AI, 3 times higher than the last generation Ada. And we need all of it to generate those pixels that I showed you. 380 ray tracing teraflops so that we could, for the pixels that we have to compute the most beautiful image you possibly can. And of course, 125 shader teraflops. There's actually a concurrent shader teraflops as well as an integer unit of equal performance. So 2 dual shaders. One is for floating point, one is for integer. G7 memory from Micron, 1.8 terabytes per second, twice the performance of our last generation. And we now have the ability to intermix AI workloads with computer graphics workloads. And one of the amazing things about this generation is the programmable shader is also able to now process neural networks. So the shader is able to carry these neural networks, and as a result, we invented neural texture compression and neural material shading. As a result of that, you get these amazingly beautiful images that are only possible because we use AIs to learn the texture, learn the compression algorithm, and as a result, get extraordinary results. Okay, so this is likely to be a multi-trillion-dollar opportunity. Well, let me show you some of the blueprints that we've created and some of the work that we've done with our partners with these AI agents.
AI agents are the new digital workforce, working for and with us. AI agents are a system of models that reason about a mission, break it down into tasks, and retrieve data or use tools to generate a quality response. NVIDIA's agentic AI building blocks, NIM pre-trained models, and NeMo framework let organizations easily develop AI agents and deploy them anywhere. We will onboard and train our agentic workforces on our company's methods, like we do for employees. AI agents are domain-specific task experts. Let me show you 4 examples. For the billions of knowledge workers and students, AI research assistant agents ingest complex documents like lectures, journals, financial results, and generate interactive podcasts for easy learning.
By combining a UNet regression model with a diffusion model, CoreDiff can downscale global weather forecasts down from 25 kilometers to 2 kilometers.
Developers, like at NVIDIA, manage software security AI agents that continuously scan software for vulnerabilities, alerting developers to what action is needed. Virtual Lab AI agents help researchers design and screen billions of compounds to find promising drug candidates faster than ever. And video analytics AI agents built on an NVIDIA Metropolis blueprint, including NVIDIA Cosmos Nematron vision language models, Llama Nematron LLMs, and NeMo Retriever. Metropolis agents analyze content from the billions of cameras generating 100,000 petabytes of video per day. They enable interactive search, summarization, and automated reporting, and help monitor traffic flows, flagging congestion or danger. In industrial facilities, they monitor processes and generate recommendations or improvement. Metropolis agents centralize data from hundreds of cameras and can reroute workers or robots when incidents occur. The age of agentic AI is here for every organization.
You download it and it should just run. And so our focus is to turn Windows WSL2, Windows PC, into a target first-class platform that we will support and maintain for as long as we shall live. And so this is an incredible thing for engineers and developers everywhere. Let me show you something that we can do with that. This is one of the examples of a blueprint we just made for you.
Generative AI synthesizes amazing images from simple text prompts. Yet image composition can be challenging to control using only words. With NVIDIA NIM microservices, creators can use simple 3D objects to guide AI image generation. Let's see how a concept artist can use this technology to develop the look of a scene. They start by laying out 3D assets created by hand or generated with AI. Then use an image generation NIM, such as Flux, to create a visual that adheres to the 3D scene. Add or move objects to refine the composition. Change camera angles to frame the perfect shot. Or reimagine the whole scene with a new prompt. Assisted by generative AI and NVIDIA NIM, an artist can quickly realize their vision.
NVIDIA AI for your PCs. Hundreds of millions of PCs in the world with Windows, and so we could get them ready for AI.
Scale. Here, Foxconn tests heterogeneous robots in a virtual NVIDIA Blackwell production facility. As the robot brains execute their missions, they perceive the results of their actions through sensor simulation, then plan their next action. Mega lets developers test many robot policies, enabling the robots to work as a system, whether for spatial reasoning, navigation, mobility, or dexterity. Amazing things are born in simulation. Today, we're introducing NVIDIA Isaac GR00T N1. GR00T N1 is a generalist foundation model for humanoid robots. It's built on the foundations of synthetic data generation and learning in simulation. GR00T N1 features a dual system architecture for thinking fast and slow, inspired by principles of human cognitive processing. The slow thinking system lets the robot perceive and reason about its environment and instructions, and plan the right actions to take. The fast thinking system translates the plan into precise and continuous robot actions. GR00T N1's generalization lets robots manipulate common objects with ease and execute multi-step sequences collaboratively. And with this entire pipeline of synthetic data generation and robot learning, humanoid robot developers can post-train GR00T N1 across multiple embodiments and tasks across many environments. Around the world, in every industry, developers are using NVIDIA's 3 computers to build the next generation of embodied AI. It began here. The first industrial revolution. Watt's steam engine and the mechanized loom introduced automation and the advent of factories. An industry was born. The age of electricity. Ampere unraveled electromagnetism. Faraday built the first electric generator, and Maxwell laid the foundations for modern electrical engineering. Siemens and Wheatstone's dynamo, the engine of electricity, bringing machines, trains, factories, and cities to life, electrifying the planet, igniting modern manufacturing. And today, born out of the computing and information age, the fourth industrial revolution, the age of AI, reimagining every part of industry. Across the continent, industrial AI is taking hold. From design to engineering, you're blazing new trails toward understanding and reinvention. You brought the physical world into the virtual to plan and optimize the world's modern factories. You're building the next frontier, where everything that moves is robotic. Every car, an intelligent, autonomous agent, and a new collaborative workforce to help close the global labor shortage gap. Developers across the continent are building every type of robot, teaching them new skills in digital twin worlds and robot tubes, preparing them to work alongside us in our factories, warehouses, the operating room, and at home. The fourth industrial revolution is here, right where the first began. Blackwell is an engineering marvel. It begins as a blank silicon wafer. Hundreds of chip processing and ultraviolet lithography steps build up each of the 200 billion transistors, layer by layer, on a 12-inch wafer. The wafer is scribed into individual Blackwell die, tested and sorted, separating the good dies to move forward. The chip-on-wafer-on-substrate process attaches 32 Blackwell dies and 128 HBM stacks on a custom silicon interposer wafer. Metal interconnect traces are etched directly into it, connecting Blackwell GPUs and HBM stacks into each system-in-package unit, locking everything into place. Then the assembly is baked, molded, and cured, creating the Blackwell B200 superchip. Each Blackwell is stress-tested in ovens at 125 degrees Celsius and pushed to its limits for several hours. Robots work around the clock to pick and place over 10,000 components onto the Grace Blackwell PCB. Meanwhile, custom liquid cooling copper blocks are prepared to keep the chips at optimal temperatures. At another facility, ConnectX-7 SuperNICs are built to enable scale-out communications, and Bluefield 3 DPUs to offload and accelerate networking, storage, and security tasks. All these parts converge to be carefully integrated into GB200 compute trays. NVLink is the breakthrough high-speed link that NVIDIA invented to connect multiple GPUs and scale up into a massive virtual GPU. The NVLink switch tray is constructed with NVLink switch chips, providing 14.4 terabytes per second of all-to-all bandwidth. NVLink spines form a custom blind-mated backplane with 5,000 copper cables connecting all 72 Blackwells, or 144 GPU dies, into one giant GPU, delivering 130 terabytes per second of all-to-all bandwidth, more than the global internet's peak traffic. From around the world, parts arrive, to be assembled by skilled technicians into a rack-scale AI supercomputer. In total, 1.2 million components, 2 miles of copper cable, 130 trillion transistors, weighing nearly 2 tons. Blackwell is more than a technological wonder. It's a testament to the power of global collaboration and innovation, fueling the discoveries and solutions that will shape our future everywhere. We are driven to enable the geniuses of our time to do their life's work, and we can't wait to see the breakthroughs you deliver.